Hello, my dear students, and welcome. Today, we are going to start a very important topic from your first unit, electric charges and fields. We'll begin with the most basic idea, electric charge. Now, I know some of you find it a little confusing, but trust me, by the end of this session, it will feel very simple. Getting this right is the key to scoring full marks. So let's get started. Chalo!
Right, so let's begin our journey into electric charge with a simple, everyday mystery. I'm pretty sure every single one of you has experienced this.
You know that feeling, right? Especially in dry weather, you take off a synthetic sweater or a jacket and you hear this crackle sound, or maybe a touch a metal doorknob and zap, you get a tiny little shock. Have you ever stopped to wonder what is actually happening there?
Well, the answer to that little mystery is the hero of our story today, electric charges. Yep, that little spark, that crackling sound, that is literally physics happening right in front of you. And today, we're going to understand exactly how it all works.
So, what really is an electric charge? What are these tiny things? To understand this, let's go straight to the classic experiment, the one that's mentioned right there in your NCERT textbook. It's the perfect way to build this whole concept right from the ground up.
Okay, so just picture this. We have a simple glass rod in one hand and a piece of silk cloth in the other. Now, before we do anything, both of these are electrically neutral. What does that mean? It just means they have a perfect balance of positive and negative stuff inside them. For now, they're just normal.
Now, here's where the action starts. When you rub the glass rod with a silk cloth, that rubbing action, that friction, gives some energy to the tiny particles. And what happens? These tiny, negatively charged particles called electrons literally jump from the glass rod and land on the silk cloth.
Okay, so think about what just happened. The glass rod, it lost some of its negative particles, the electrons. So now, it has more positive particles than negative. Simple, right? So it becomes positively charged. And the silk cloth, it gained all those extra negative electrons, so it becomes negatively charged. See, one loses electrons and becomes positive, the other gains them and becomes negative. Now, this idea of being either positive or negative has a proper name in physics. We call it the polarity of charge. And it's really simple. There are only two kinds of polarity, positive and negative. And it's this difference that's responsible for all the electric forces we're about to study.
And that brings us to the number one most important rule of this whole chapter. This is straight from your textbook, and you have to remember it. It says, like charges repel, and unlike charges attract each other. This, my students, is the golden rule of electrostatics. Never, ever forget it.
So what does that rule really mean? It's just this. If you bring two positive charges close, they will push each other away. They repel. If you bring two negative charges close, same thing. They also push each other away. But if you bring a positive and a negative charge near each other, they pull towards one another. They attract. Opposites attract. It's that simple, isn't it?
Now, if you want to really master this topic for your exams, there are three basic properties, or let's call them rules of charge, that you must know. They are super logical and absolutely essential. So let's go through them one by one.
Okay, here are the three pillars. First is additivity. This just means that charges add up like regular numbers. You just add them, keeping their plus or minus signs in mind. Second, conservation. This is a huge law in physics. It means you can't just create charge out of thin air, and you can't destroy it either. The total charge in a closed system will always remain the same. And third is quantization. This one's really interesting. It means charge comes in fixed little packets. Think of it like money. You can have 1 rupee, 2 rupees, 10 rupees, but you can't have 1.5 rupees, right? Charge is like that. It comes in multiples of a tiny fundamental packet.
All right, let's take a quick look at that first property, additivity. And don't worry, this isn't complex calculus or anything. It's literally just the simple addition and subtraction you learned in primary school. Let me prove it with a quick example.
So imagine you have a box, and inside it are 5 different charges, a +1, a +2, a -3, a +4, and a -5. Now, if I ask you what is the total charge of the system, what do? You just add them all up.
And the answer is -1. That's it. That is the entire principle of additivity. See, I told you it was simple math.
Okay, now please pay close attention. This part is where a lot of students make small mistakes and lose easy marks in the exam. I call them silent killers. Let's make sure you don't fall into these common traps.
A common point of confusion is the difference between mass and charge. Let's clear it up. Mass, as you know, is always positive.
But charge, it can be positive or negative. Next, charge is always conserved in an isolated system, but mass is not. We know from Einstein's famous equation, E equals mc squared, that mass can be converted into energy. And finally, charge is quantized. It comes in those fixed packets we talked about. Mass, for our purposes, is considered continuous. Please remember these key differences.
So let me be absolutely 100% clear on this point, because this is the biggest misconception. When we rubbed that glass rod with the silk, we did not create any new charge. No, all we did was transfer charge. The electrons simply moved from one place to another. So if the rod lost, let's say, 100 electrons, then the silk gained exactly 100 electrons. The total charge of the system, the rod and the silk together, never changed. That is the law of conservation of charge.
Fantastic. We're on the home stretch now. Let's just quickly see how this topic connects to what you'll study next, and then we'll do a rapid-fire summary for your final revision.
So why is this so important? Why are we spending so much time on it? Because बच्चों, understanding charge is the foundation for everything that comes next. Topics like Coulomb's law, which tells you the force between charges, the whole idea of electric fields, and even the chapter on current electricity. All of it depends on you having a crystal clear understanding of what electric charge is. It's the first step of the ladder.
Okay, final revision time. If you forget everything else, just remember these 4 key points for your exam. 1. There are 2 types of charge, positive and negative. 2. The golden rule, like charges repel, unlike charges attract. 3. Charge is conserved. It's only transferred, never created or destroyed. And 4. Charge is quantized. It exists in discrete packets based on that fundamental unit, E. Got it?
And I'll leave you with one final question to think about. We've established that charge is always conserved, that you can't create it from nothing. So that begs the question, doesn't it? Where did all the positive and negative charge in the entire universe come from in the first place? It's a fantastic question, and the answer is a beautiful story in physics. But that's for another day. All the best with your study.